National Electrical Code Section 300.22 addresses raceway entry of conductors. Subsection A covers cables and raceways, stating that the number of conductors permitted in a raceway, cable, or enclosure shall not be such as to cause a temperature rise detrimental to the insulation of the conductors. Subsection B addresses cables and openings. Where cables are installed through walls, floors, attics, or similar areas, the cable shall be protected at the point where the cable enters the opening to prevent damage to the cable. Section 800.53 covers raceways for sign, outline, and canopy wiring. Subsection B addresses wiring. Conductors within raceways shall be installed in accordance with the provisions of Article 300. Section 800.113 covers electrical equipment in the ceiling space. Subsection addresses equipment accessible from below. Electrical equipment installed in the ceiling space of buildings and accessible from below shall be installed on a switchboard, panel board, or other approved support. There are exceptions to this rule. Exception 1 states that motors and appliances specifically listed for installation in ceiling spaces, such as recessed luminaires, surface-mounted luminaires, or lighting panels, shall not be subject to this requirement. Exception 2 states that transformers with an input voltage not exceeding 600 volts and an output voltage not exceeding 30 volts shall not be subject to this requirement. Exception 3 states that communication equipment such as telephone and telegraph equipment shall not be subject to this requirement. Based on these code references, there are no specific restrictions in the National Electrical Code that explicitly prohibit running alternating current or direct current power cords and data lines, such as coaxial and telephone wire, through the same pipe. However, several important considerations must be addressed to ensure safety and code compliance. Firstly, the pipe or conduit must be adequately sized to accommodate all conductors. Overfilling a conduit can lead to overheating and potential damage to the insulation of the conductors. The National Electrical Code provides tables specifying the maximum allowable fill for various conduit sizes and conductor types. Refer to these tables to determine the appropriate conduit size for the specific application. Secondly, it's crucial to manage heat generation within the conduit. While the code does not explicitly forbid mixing power and data cables, it emphasizes preventing temperature rise detrimental to the insulation of the conductors. Power cables generate heat due to current flow, and data cables can be sensitive to excessive heat. Separating power and data cables can minimize potential interference and heat-related issues. However, if they are run together, ensure adequate ventilation and consider using conductors with higher temperature ratings. Thirdly, proper conductor securing is essential. All conductors within the pipe must be properly secured to prevent movement and potential damage. Use appropriate fittings and supports to maintain the integrity of the wiring system. Fourthly, consider electromagnetic interference. Power cables can generate electromagnetic interference that may affect the performance of data cables. Shielded data cables can help mitigate this interference. Ensure that the shielding is properly grounded to provide effective protection. Fifthly, adhere to local codes and regulations. Electrical codes can vary depending on the jurisdiction. Always consult with the local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes and regulations. A qualified electrician can assess the specific installation requirements and provide guidance on the best practices for running power and data cables together. They can evaluate the load requirements, conduit sizing, temperature considerations, and potential interference issues to ensure a safe and compliant installation. Here's a more detailed look at the NEC sections mentioned, expanding on their implications for running power and data cables together. Section 300.22 Raceway Entry of Conductors emphasizes the importance of protecting conductors as they enter raceways or enclosures. This section aims to prevent physical damage to the conductor's insulation, which could lead to short circuits, ground faults, or other electrical hazards. Subsection A, Cables and Raceways, focuses on the number of conductors within a raceway. The key principle here is to prevent overcrowding, which can lead to excessive heat buildup. The allowable number of conductors depends on factors such as the type of conductor, the size of the raceway, and the ambient temperature. The NEC provides tables, specifically in Chapter 9, that specify the maximum allowable fill for different types of raceways and conductors. These tables take into account the cross-sectional area of the conductors and the internal area of the raceway. It's crucial to consult these tables to ensure that the raceway is not overfilled. Overfilling a raceway can restrict airflow, leading to increased temperature and potentially damaging the insulation of the conductors. In addition to the fill limitations, it's also important to consider the ampacity of the conductors. Ampacity refers to the maximum current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables, such as Table 310.15b16, that specify the ampacity of different conductor types based on their size and insulation. When conductors are installed in a raceway, their ampacity may need to be adjusted based on factors such as the ambient temperature and the number of current-carrying conductors in the raceway. These adjustment factors are outlined in NEC Section 310.15. It's important to apply these adjustment factors correctly to ensure that the conductors are not overloaded, which could lead to overheating and insulation damage. Subsection B, Cables and Openings, addresses the protection of cables as they pass through walls, floors, attics, or similar areas. The primary concern here is to prevent physical damage to the cable due to abrasion, sharp edges, or other hazards. The NEC requires that cables be protected at the point where they enter the opening. This protection can be provided by various means, such as using a bushing, grommet, or conduit fitting. The specific type of protection required depends on the type of cable and the nature of the opening. For example, if a cable is passing through a metal stud, a bushing or grommet should be used to protect the cable from abrasion against the sharp edges of the stud. Section 800.53, Raceways for Sign, Outline, and Canopy Wiring, provides specific requirements for wiring in signs, outline lighting, and canopies. While this section is primarily focused on these specific applications, it also provides general guidance on the installation of conductors and raceways. Subsection B, Wiring, simply states that conductors within raceways shall be installed in accordance with the provisions of Article 300. This means that all the general requirements for raceway installations outlined in Article 300 apply to wiring in signs, outline lighting, and canopies. This includes requirements for conduit fill, conductor ampacity, and protection of conductors. Section 800.113, Electrical Equipment in the Ceiling Space, addresses the installation of electrical equipment in ceiling spaces. This section is particularly relevant to the installation of audiovisual equipment suspended from the ceiling. Subsection A, Accessible from below, requires that electrical equipment installed in the ceiling space of buildings and accessible from below be installed on a switchboard, panel board, or other approved support. This requirement is intended to ensure that the equipment is properly supported and accessible for maintenance and inspection. The exceptions to this rule provide some flexibility for certain types of equipment. Exception 1 allows motors and appliances specifically listed for installation in ceiling spaces, such as recessed luminaires, surface-mounted luminaires, or lighting panels, to be installed without a switchboard, panel board, or other approved support. This exception recognizes that these types of equipment are typically designed to be self-supporting and do not require additional support. Exception 2 allows transformers with an input voltage not exceeding 600 volts and an output voltage not exceeding 30 volts to be installed without a switchboard, panel board, or other approved support. This exception recognizes that these low-voltage transformers are typically small and lightweight and do not require additional support. Exception 3 allows communication equipment such as telephone and telegraph equipment to be installed without a switchboard, panel board, or other approved support. This exception recognizes that communication equipment is typically low power and does not pose a significant electrical hazard. In summary, while the NEC does not explicitly prohibit running alternating current or direct current power and data cables together, it's crucial to consider the potential hazards and follow best practices to ensure a safe and compliant installation. Always consult with a qualified electrician to assess the specific requirements of the installation and provide guidance on the best approach. In addition to the National Electrical Code considerations, there are also practical considerations to keep in mind when running power and data cables together. Firstly, physical separation can reduce interference. Even with shielded data cables, maintaining some physical separation between power and data cables can help minimize electromagnetic interference. This can be achieved by using separate conduits or raceways, or by running the cables along different paths. Secondly, cable management is important. Proper cable management is essential for maintaining a neat and organized wiring system. Use cable ties, straps, or other cable management accessories to keep the cables bundled together and prevent them from becoming tangled or damaged. Thirdly, labeling is helpful. Labeling the cables at both ends can make it easier to identify and troubleshoot problems in the future. Use clear and durable labels that are resistant to fading or abrasion. Fourthly, future expansion should be considered. When planning the wiring system, consider the potential for future expansion. It's often easier and more cost-effective to install additional conduits or raceways during the initial installation than to add them later. Therefore, always consult a qualified electrician who can thoroughly assess your specific needs and provide expert advice, ensuring that your installation is both safe and code compliant. Always stay informed about the latest updates to the National Electrical Code. Electrical codes are constantly evolving to reflect new technologies and safety concerns. Staying up to date with the latest code changes is essential for ensuring that your installations are safe and compliant. Remember that the National Electrical Code is not a substitute for professional judgment. While the code provides a comprehensive set of rules and guidelines, it cannot address every possible situation. It's important to use your own judgment and experience to make informed decisions about electrical installations. If you're unsure about any aspect of an electrical installation, it's always best to consult with a qualified electrician.